Good morning. Good
Good
evening
morning.
to you.
Actually, it's a good evening and good morning and good afternoon. We have many participants from different countries. How are
Good
you,
evening.
President Maria? How are you, Dr. Chae Li?
Very
Good.
good.
Yes,
Yeah.
thank you for joining us today. It's a great pleasure and honor to have you today. First of all, I would like to welcome you all to this very valuable webinar. I encourage all of you to share your time and location in the chat box. I can see we have different participants from several countries, but I can see that World Cup match is affecting the attendees. Hopefully, they can catch us soon. My name is Mohamed Ezzat. I'm Assistant Professor of Civil and Environmental Engineering at Prince Sultan University, and also the Faculty Advisor of the Prince Sultan Student Chapter. Today we will discussing the resilience infrastructure future. As all of us knows, with the recent changes experienced in the climate, early infrastructure could be expected much more than previous. In this seminar, in this webinar, we will try to introduce the emerging trends and the new technology mainly dedicated to developing resilient infrastructure solutions that could be more sustainable for the future challenges. We will also try to present the most promising ASCE future world vision that also suggests many innovative ideas for the civil engineering future. First of all, I would like to extend a special warm welcome to our distinguished speaker who will join us today. Today we have President Maria Lehman, the 2023 ASCE President. President Maria is GHD's infrastructure market leader for the United States. She was also the former vice president for the critical infrastructure of Parsons. She has 40 years of diverse, increasingly responsible and multidisciplinary technical and leadership experience, both in the private and public sector. She received her BS in Civil Engineering at the State University of New York at Buffalo, and she is a licensed professional engineer in several states. She has served as a principal in the charge, project executive, program and program manager, and project engineer on more than 700 projects. President Maria has won a large number of national, statewide, and local awards, including the AST President Medal, Edmund Friedman Young Engineer Award, UBS School of Engineering Alumni of the Year, and the New York State Society of Professional Engineering Manager of the Year. Finally, President Maria was recently appointed as Vice Chair of the U.S. Presidency Advisory Council of the National Infrastructure in IAC. The Council advises the White House on how to reduce physical and cyber risks and improve the security and resilience of the national critical infrastructure sector. Welcome, President Maria. Nice to have you today.
Thank you so much for having me.
Our second distinguished speaker for today is Dr. Chae Li. Dr. Chae obtained his master and doctorate degree from Stanford University. He is also expert in geomechanics, numerical simulation, with 23 years of experience in research, design, and construction. He worked as a Director of Technology and Business Development in Q1 On Construction Company in Hong Kong, China. Dr. Chae Li is currently the ASCE Region 10 Governor and Adjunct Professor in Hong Kong University of Science and Technology. He also was the past President of ASCE Greater China Section. Very soon we will have our third distinguished speaker. He asked it for 5 or 10 minutes delay. Mr. Mohamed Amer. Mr. Mohamed Amer is Managing Director of the Transportation Development Institute, TNDI, and also is managing the Future World Vision. He is the transportation engineering professional responsible for leading the transportation and development program and activities at ASCE. Mr. Amer holds a master's degree in civil and transportation engineering from Bordeaux University. He also has over 23 years of combined experience in civil and transportation engineering program development and management, federal, state, and local government grant development and management, with a strong background in federal acquisition regulation, technical consulting, and team leading on multi-million-dollar program. Mr. Amer has experience working with the best of the best transportation industry, including leading practicing engineer, academics, and public sector official. Once again, thank you all for being with us today. Our first topic today was President Maria. She will talk about the engineering future. Floor is yours, President.
All right. Can you see the slides okay?
Yes.
All right. Just want to make sure we're all set. So I want to spend the next 20 minutes or so talking about ASCE and what we're doing to engineer the future, how we're preparing civil engineers, and some of the programs we're having. Mohamed Amer is going to come on a little later, and he'll talk more specifics on future world vision and do more of a deep dive, but I'll do some high-end things on what we are doing in the U.S. specifically and actually how it fits globally. So first of all, I'd like to talk about the fact that civil engineers are the cornerstone of everything that happens in modern society. But unfortunately, we are not a seen entity for the most part. What we do, unless something is a catastrophic failure, people really don't know or understand what we do. And so it's really important for us to be able to worldwide have people understand what it is that we do and why it is so important. So as we're looking towards the future and we know the challenges that we're facing, it's really important that we communicate this not just internally within ASCE and our membership, but externally as far as what we're doing. The world surpassed 8 billion people last week, actually. And so the challenges are about an increasing population, about climate change across the world, and how that's impacting individuals. And so it's really important that we use our best tools. So a few years ago, the Industry Leaders Council of ASCE, which is really C-suite individuals that are asked to join to talk about what is coming in our profession, that we are on top of where we need to be. And one of the conversations was that our previous plan was 2025, or 25-year plan, and it's coming due. What do we do next? And so the Industry Leaders Council said, we have to think about 50 years in the future because those things are going to impact what we do today. And so we came up with a number of ideas that we wanted to deal with. Unfortunately, COVID happened in the middle of it. And so fundraising, this is a very ambitious project. And we'll talk more specifically about details. But we decided to invest our money in developing one of the 5 use cases, which is Mega City. And I am going to now go to actually the sizzle reel that was developed so you have an idea of what's included. And we're going to see if it's going to work or not. There we go. Can you see and hear that?
We can see, right?
Are people getting sound?
It's too low, but there is a sound. You are muted, President.
Sorry.
Yes.
Let me stop it and keep moving. This is available on ASCE's website. I think part of the issue has to do with the fact that I'm, almost a world away, and so it buffers. The issue is with buffering. One of the reasons why I was hoping you could run it, 'cause then it doesn't have the issues. Um, Future World Vision, and this video is available in its beta form right now on ASCE's website. You can download the desktop version or the computer version, if you're an ASCE member right now, and so you can get a better idea. The whole intent is that we are designing more purposefully for the next 50 years, because the more we think about the future, the more it impacts what we're doing today. And so it's really important, from an understanding standpoint, that we have that information. And so again, this 7-minute reel is available on ASCE's website, as is the whole platform. And I'll talk a little bit more about it, and Mr. Amer will as well. And it's not letting me close it. Let's see here. Okay. Okay, and so as ASCE is moving forward, we really need to give you the tools, the future civil engineers, the ability to matter more and lead those projects of the future, so you can make a bigger difference in how we impact. And this is becoming more and more difficult. If you look for specifically ASCE 7, which is the worldwide structural standard for minimum design loading, in 1995, when this came to light, that standard only had 236 pages in it. ASCE 722 has almost 1,100 pages. And for the first time, we're actually looking at tornado loading, for example. And so the more complicated our projects get, and the more we have to worry about both climate and man-made challenges to our infrastructure, it becomes more important not only to understand the technical challenges, but also how do we communicate that to the decision makers, who in many cases are not technical. ASCE has redone its website, the source. It gets data from all across the world. And as you look at things on ASCE's website, if you get the daily email for data, we use AI. So it goes to articles that would interest you based on what you're interested in. So maybe it's geotechnical engineering, or maybe it's public policy in Australia. If you go to those areas on the website and look at them, the AI will actually bring you articles as they come to light. So we're trying to be responsive to member needs around the world. We're obviously very interested in being stewards of our infrastructure. We don't want to be rebuilding things every 10 years, because climate change is destroying them. It's very important that we really think about the fact that we are the stewards of human health, safety, and welfare. And so we have to build not just projects right, but the right projects, things that really transform and make the world a better place, and allows for long-term development. We're also very interested in developing leaders. So we do leadership conferences around the country. We do several outside of the United States. We do a lot of webinars in this area, so that you can understand those things that we used to call soft skills, which are not soft skills, there's power skills. Being able to be a good technical writer, being able to talk to a local media person, being able to present in front of a group. You're not leading projects if you can't do that. You can have all the technical knowledge in the world, but you have to be able to present it. And so we do all kinds of seminars in this area, because people tend to be good in math and science that are drawn to engineering, but maybe they're not as good at some of the public outreach and public speaking roles. Every survey that has ever been out in the last probably 20 years said people are more afraid of speaking in public than they are of dying. And so that's kind of scary that we have to, work on those kinds of skills, but we do. And it's very important if we're going to lead these big projects for the future that we can talk about them. A little bit about our report card. We started the ASCE report card. Now, this is a U.S. model, but we are getting some interest from around the world to doing this in other countries. We started this in 1998. And we've been doing it every 4 years ever since. For the first time ever since we started, we actually got a cumulative average of over a D. So we have been in the D to D plus range for the last 2.5 decades. We look at a lot of different things, and we look at publicly available data, so that if you got a group of 20 or 30 engineers to sit down and look at that data, they could come to the same conclusions. And we basically look at not only how it's doing now, but how is it fit for the future? Is it resilient? All those things. Many of the grades stayed the same. Several went up. Drinking water went up because of investments. Energy went up because of investments. Inland waterways and ports as well. Bridges went down. Because for the first time since we've taken statistics, even though there's more structurally deficient bridges in the United States, there's less than there used to be. There are more bridges that are in fair and poor condition than there are bridges in good condition, which is not a good long-term statistic. Thanks to the report card and all the work that's been done in all the media and a lot of outreach, we got what was first called the Infrastructure Investment and Jobs Act, now is being called the Bipartisan Infrastructure Law, where $1.2 trillion is being invested in 5-year time, where we just passed a year a couple of weeks ago. Of that, $500 billion is new money, federal money. So there's many, many areas that have not been invested in that will be now. And what's important to note is that of our 17 categories, all 17 saw investment. And of our 70 plus initiatives that we said had to be taken on, over 40 were part of that bill. So it is the largest investment in more than a generation, and it's the most comprehensive. So we're very proud of that, but we have to deliver. Now we have to deliver. We've been complaining about not enough money. Now we have to make sure we do the right things. So part of our future world vision, just like we did with building big, dream big, a few years back, we are doing the same kind of rollout as far as going to science museums. And this is something that has global potential as well. So we signed an agreement with the same company that helped us when we did Dream Big, and I laugh and call this Dream Bigger. So we're going to take all the things that we're doing with Future World Vision, it's embedded into an IMAX film, along with hands-on activities for middle school students around the world to be able to participate. It's a full-length IMAX feature. And so when you think about our Dream Big, you can get it on a lot of social media areas. You can actually see it. Alaska Airlines, you can watch it on the plane, for example. So it's not just about outreach and Future World Vision. It's also about getting students that are now in programs excited about what the potential future is. But it's also for people like us who are practitioners to have a community of practice where we can question and we can have an open dialogue about how we might handle some issue in the future. So this will, we're underway now. Like I said, we're still beta. This will be available as of our convention in Chicago next October. And so it will be finalized as a platform for Mega City, as well as this piece, which is the IMAX movie for next year. So we're really excited. But like I said, you can download it now and use it as a tool now. We've actually done curricular activities around it as well for undergraduate civil engineering. A little bit about climate change and the way things have been changing from our perspective. First of all, we had the pandemic. Nobody expected all of us to be able to work from home for a long period of time, and it happened, or learn from home, quite frankly. We've also had this renewed focus, and ASCE calls it JEDI, Justice, Equity, Diversity, and Inclusion. So making sure that we have the right pipeline of individuals ready to deliver the infrastructure. There's very few countries that have a whole lot of engineers sitting around not doing anything. Most countries are having issues with having enough engineers to do what we have to do. We talked about the bipartisan infrastructure law and climate change, and so we have to have both internal and external communications. So just to give you an idea of what this looks like, again, being asked to look at the U.S. model, this was last December of how many? We had 22 separate events that caused more than $1 billion worth of damage in the United States. And the year before, 2020, was the record to that. And this year alone, Hurricane Ian, which hit Florida, is anticipated to cost somewhere between $40 and $60 billion. And so we're talking huge numbers. We have to do better at how we do that. This is kind of where the disasters were and the types. So we have everything from too much water to severe drought, depending on where you are. We're seeing flooding. We're seeing wildfire issues, tornadoes. And so all of these, as you look at all these changes, I'm very proud that we charged a subcommittee of our Strategic Advisory Committee of the board to work on a new 5-year strategic plan, because while we felt overall our vision and mission was close to what we needed, everything changed from a strategy and tactics standpoint. And so we really needed to work on how we do that. And so we now have 2 pages, again, on our website, very simple, about what we expect to do in the next 5 years. And then finally, a little bit about what we are doing on the public leadership side. I'm urging everyone to step it up. As was mentioned, I'm on the National Infrastructure Advisory Council for the president as far as how we deliver better, faster, cheaper. And, the summit they had was on time, on task, and on budget, which was just a little over a month ago. We're looking at ideas from across the board on how we do things better. And so it's been thrilling to have a whole bunch of like-minded individuals that really want to do better engineering and faster and cheaper. The last slide that I want to leave you with is in Darwinian theory, it is not about the smartest or the strongest species. It's about who adapts the best to the situation they're given. I think engineers are trained as problem solvers, and so we are absolutely in a great place to lead on worldwide problems relative to society. And so we have to get comfortable with being uncomfortable. And I think we're going to have questions at the end. So I'm going to leave it at that and give it back to Dr. Ezzat to get our next speaker. Thank you.
Many thanks, President Maria, for this informative and very interesting presentation. Actually, I'm so excited to attend the IMAX movie. I can see Mr. Amer join us here. He may elaborate more in this. It's a very interesting idea. I guess my daughter Farida may be also interested to attend this movie. Okay, now it's time to move to Dr. Chae Li.
Okay.
Dr. Chae will present very interesting case studies. And now floor is yours, Dr. Chae.
Yeah, can I share my screen?
Sure.
Yeah, let me. Yeah. So let me open my PPT. Can you see it okay? Like
yes.
Full screen?
Very well.
Okay. All right. So my topic today is mostly is about sustainability, but I want to echo the president just said. We want a smarter solution, cheaper, and more sustainable, right? So I want to, because some people may think, sustainability and resilience appear to be something extra. So I want to see and also give our students, we have a lot of students coming here, a little bit example of, what does it mean for a real large infrastructure project. So here are some photos that I recently shoot in Hong Kong and the neighborhood region. You can see even in a very developed area like Hong Kong, civil engineers always have plenty of work to do. So if I start from left and from top to down, you can see to the very left is the excavation, supported excavation. You have the stars and the ship house supporting the excavation. In the middle is the roadworks near the center, very like central of Hong Kong. And to the right is a renovation project for old style of cinema covered by this green temporary works. And then now to the second row, we have a bridge which is the view from the bottom up. You can see, very long piers, and then the bridge goes from the sea to the hill. And then you have a new apartment building under construction, where we have in Hong Kong, it's a character that we have a large transfer story. You can see it's well actually, if you talk to a seismic expert, he'd be not, it's probably not the best structure you can have. But in Hong Kong, seismicity is low, similar to Egypt, maybe even less. So like, people want some, large space for parking. And then we have a geotechnical investigation works right next to that. And to the very right, lower right, we have this, it's a concrete grillage and soil nails to protect the slope. You can see, no matter where you are, developing country or developed regions, you always have civil engineers who can continuously improve our built environment or our very essential infrastructure to make our life better. So I just want to echo that civil engineers are always making positive contribution to the society, no matter where you are. And then one of the arguments I want to make is that the civil engineering, at least when I were in the university, like more than 20 years ago, you always consider it as a traditional profession. Although in the past like 20 years, a lot of things has changed, especially the use of computer methods, right, in the civil engineering. And but in the last 10 years, even more technology advancement has happened. And we have ever more severe environmental problems, and we have a lot of constraints and limitations for all our projects. And also the interface issue between design and construction become more and more severe. And then also as a contractor or as a designer, you got to be also aware of the contractual and commercial and legal issues, right? And then particularly in terms of tender, how the industry can overcome the lowest bid of this, which is causing a lot of problem for our industry. That's a problem for everywhere almost. So now also let's take a step back and think about what are the characteristics for the large scale infrastructure projects. I think one of the things is it is more than ever multidisciplinary. It has architectural, civil engineers, including structural, geotech, transportation, all these kind of civil engineers, environmental engineers. You have MEP, which is mechanical, electrical, and plumbing, right? So in the construction projects, all of these engineers works for civil engineers. So basically, we are the leader, right? And then for large infrastructure project, you also have many different work fronts, right? So have a lot of procedures, complex construction sequence, right? So, and then in terms of design construction, sometimes you have to work in a very densely populated area, right? No longer like in a very, in some place like nobody lives, right? Many times you work with constraints. And then of course, for large projects, you need a lot of people, a lot of plans, longer duration and high uncertainty. So all this make our jobs a lot more complex than before. Right, and one of the questions I want to ask our students is, what do you think, is this equation true, right? Is it construction just like a design plus some cost, some funding, right? So, and then if we can take a, reflect again about what is design, what is construction. So the design, probably most people know, it means how the thing supposed to be looks like, right? So we also broadly divide the design into permanent design and temporary works design. For permanent design, we mean the final condition. It may or may not involve any contractor. There's a designer or consultant who can finish this permanent design. But the temporary works design normally would involve a lot of participation from the contractor, because the contractor has to figure out how to do it. So most straightforwardly, people would think that construction is, you kind of magically change the design drawing to a three-dimensional reality, right? But that's rarely the case, even if you have a perfect design, because the design, in the narrow sense, simply show a list of all the elements that you want, right? But not the sequence. And actually, many of the design elements cannot be put into place without major temporary works. For instance, if you want to build an arch dam, right, you can't just put a piece of the element just there, right? You have to work out with the soil, with the rock, with the temporary works. So, and then in terms of design optimization, also, if some of you have studied construction management, you probably have seen this chart. The horizontal axis is the project time, right? From the start to the finish of construction and to the start of the operation, right? We can see, and then the vertical axis is the level of influence on cost. We can see that if you can change the design in the very beginning, you obviously have the greatest influence over the overall cost. But as time goes on, particularly after you enter your construction stage, the level of influence is greatly reduced, right? So, and then why people may ask, why is always design optimization possible? Why can't we do the job perfectly in the beginning? I want to bring a few perspectives. Firstly, from the geotechnical engineering part. Normally, we rely on the ground investigation data. There's a lot of uncertainty, and then it will be normally you have a small amount of ground data before you get the job. And after you get the job, and then you need to do it, particularly for large infrastructure projects, you are going to get like 10 times more data than before the construction. So there's no reason why you shouldn't make use of those data and make your design better. Right. From the structural engineering part, there are a lot of, you have a preliminary analysis, but during construction, firstly, you have access to a lot of information, like the GI information. Similarly, you may probably got the time for wind loading, for instance. You probably have done a wind tunnel test, so you have a more accurate loading condition. And also, we can do the optimize this design for the process of construction, installation, and transportation. Sometimes you need a large precast element from elsewhere to the construction site, right? So you need to optimize for transportation as well. And the third element I want to point out is the monitoring data. Nowadays, our construction site is also a little bit like more like a lot of eyes watching at our site, right? We're collecting a lot of information on the water pressure, movement, and then the response of the, probably partially complete structure under loading. So all this data can be used for further optimization. And then how can we do it? For instance, in geotechnical engineering, it's possible that you can use some big data technology, right, to deal with the data, which we can show with some example a bit later. And the structural part, we can, for instance, for the wind load, earthquake load, and wave loadings, you can have more advanced analysis during the construction stage based on the more information. And then construction itself is a dynamic process. So you can, of course, do some further optimization. And at last, I want to mention about the design code, which is the fundamental change that's required to suit for this current digital revolution, right? Digital construction. And then the government approval process also can be further optimized. So here I show one example that when I started working in 2003, this is when I was working in New York. I see one of the engineer use this simple one page to do the calculation for a subway station. Well, you can see it's a very neat calculation. Right now, not a lot of engineers are still familiar with this. And nowadays, many of these calculations can be done in a computer by finite software and can be done more accurately. But still, we would need this hand calculation to calibrate our computer simulation. And here I want to show in terms of geotechnical engineering what I mean by the data. You see here is a plot of the soil data, which is SPT, which is standard penetration test. Basically, it is the measurement of the strength of the soil in situ by dropping a hammer and a splitter into the ground, and then measure the resistance per penetration, right? So like it's the penetration of 300 millimeter of soil. You measure this blow count. So the higher SPT means stronger soil, right? And you can see let's only look at the first, we have 4 soil units here. We have fill, we have marine deposit, alluvium, and grade 5 rock. But the fill, you can see the data are quite scattered. And normally when we do the design, currently we assuming one set of material parameters for this soil layer. You can see how crude it is, right? And then sometimes people only use one single number, or people can use one line. So you can here I draw 3 lines. One of the red line, lower bound. Let's say the green line is the median value, and then the blue line is probably the upper bound, right? So which one you use? But no matter which one you use, you cannot exclude the possibility that data goes to the other part, right, for a certain location. So like if we can think this kind of scattered of data in terms of accuracy, so you can see accuracy can vary from 100% to 250%. And then after, this is not the end of it, uncertainty, because after you get this data, you want to figure out, many times you want to figure out, how much settlement happens, or how much deformation happens of these soils under loading. And then for this parameter, which we call Young's modulus, we don't have a direct measurement. So we normally correlate from this SPT to Young's modulus by a linear relationship. And then this factor is 1 to 3. So now we have 300% of uncertainty. You multiply these two together, you got 750% difference from the lower bound to the higher bound, right? But normally at this moment, people still, even in Hong Kong, in a very developed area, we still use one single set of analysis to do the design. You can see how this is why the design can be optimized, right? A lot of uncertainties are involved. And in terms of structure mechanics part, this one shows the excavation lateral support. We have a circular shaft and the ERS to the right. You can see for this kind of geometry, if you still just do 2-dimensional analysis, you're going to be quite conservative, because if you consider fully the 3-dimensional interaction between soil and structure, you can have on average about 20% to 30% of savings. So I think, and then another perspective is the constructability issues. To the lower part of this slide, you see a very congested, connection, which is a real case in one of the real projects. You can see how confusing it's going to be for the manufacturers to build this, right? Which part you're supposed to connect on site and which part you connect in a factory. And if you actually connect it in a factory, and how do you do the transportation? Because your truck would not be that large enough to handle this, right? And then there are a number of other things. For instance, people may be choosing the wrong type of structure in one of the soil conditions, because if you're assuming there's for instance hard soil, and you will use pre-bored pile, right? But if you happen to use the driven H pile, you're gonna have, on paper you're gonna save money, but in reality, if when it's encounter boulder, you still need to bore this boulder and then install the driven H pile, so which will cost more than the socket H pile or bore pile. So all these things you cannot know basically before the construction start. Well, the third point, another point is the building code. So in some area, at least some area of the world, the engineer normally, they say, okay, I'm doing the design based on the code, but actually the code has a lot of options, no matter ASCE code or Euro code. For particularly, if you are willing to do more sophisticated analysis for cost saving, you can, if you basically spend a little bit more on analysis, you can probably save a lot of money in terms of overall cost. So, and then the design approval is one big issue as well. In Hong Kong, we got a very rigid design approval system. Even a method not allowed by the authority, even if it's a sound practice, it probably cannot get approval. And the approval itself takes a lot of time. So basically, you know, as we're region 10, right? I'm from region 10. So region 10 covers a lot of countries with a lot of governments. So the different codes are used. So basically, we need to be aware that design approval in one country doesn't mean in another, right? So we need to be careful about that. So this is in Hong Kong. We have a building authority which collects all the like different departments, like a ferrying service department, a highway department, the different departments all come to the umbrella of building authority, which will do the design approval. You can see that's why they are executing these laws rather than like letting the engineer to decide many of the design elements. So that's one of the problems that why Hong Kong is very expensive in terms of construction cost, which is not very sustainable, you know. And overall, basically, how should we design? Think about the sustainability and resilience in relation to design. I think we got to look at the overall life cycle. So, and then we should try to reuse as much as construction material and plants, which I will give an example on the construction material, and then we will think about how we can do the carbon reduction, right? And one of the important things is on people. So because we actually need people who are in charge of the design, construction, and management. So all these people need to work together, and then to ensure that common understanding are reached to avoid the waste during the design or construction phase. And the new technology will help with that, including the particularly building information modeling. At this moment, it's pretty much still a graphical tool, but then the potential is there. And then many important infrastructure projects have already used BIM to reduce waste. And we can also Internet of Things, robotics, all of this will help us to reach our sustainability goal. And one example is, you know, recently in Hong Kong, we have completed one of the major reclamation works of the Hong Kong International Airport. We reclaimed about 650 hectares of land. And you can see that here to the right are the soils. We have the original soil in the marine deposit underlaid by alluvium. Now we need to fill above it a lot of fill material to eventually form the land above the sea level, right? So what material you use for the fill become a very important issue, because traditionally people use clean sand for reclamation. And now more and more, you know, it's realized that clean sand is actually environmental burden, right? So many places, they don't have the river sand for you to use. Even marine sand is no longer available in Hong Kong. So in this project, we have used a lot of construction waste, which are the excavated. Actually, they are not really waste. They are just the soil excavated from other construction projects. So, but then how much can you use it everywhere? How much you can use, right? So here I give you a few options, because one of the obviously the most easiest option for the designer and the contractor is to use clean sand everywhere. And we will, because in the airport, settlement is a big issue, because if your fuel material is not very good, it's going to settle, and you're going to have a lot of problem during use, right? You don't want your runway to settle half a meter after finish, right? So, but so if you use but obviously if you use clean sand, that's the most unsustainable way, right? So it's the probably I will, but if you can like use part of the soil, like say above water, you use public fill, which is the construction waste, you probably can will not affect your performance because it's above water, and you can compact the soil easily. So you can we can give it a one smiley face. And if you, with a little bit more design work, you can make it work like all this, most of the material you can use for the public field. And then a further enhancement would be, because if you go back to the picture, we have a runway here, right? So only the runway are very strict in terms of settlement performance. So if the designer and contractor can work together to make sure that the settlement are controlled within the runway, for the rest of the area, you don't need a very strict settlement criteria. So if you can do that, you can save a lot more money and make the whole thing more sustainable. Okay, so I think the time is very limited. So in terms of the superstructure, it will be similar, right? You can build a building and put it on piles, or you can work out the stress balance. So like your building, if you build a very large basement, your building probably will not cause additional settlement. So this is a little bit too complex to explore at this moment. But we need to know that the interface is changing. Before we have design, construction, and operation very separated. Right now, design, construction have some interface, construction and operation have some interface. And in the future, or probably the future is happening now, we need to find the optimal region where the three design, construction, and operation, we have to find a common goal, right? So only if we enter this region, we can call our infrastructure to be sustainable or to be a cheaper solution. So I think we will have our next speaker talking about the future world vision. So we'll, but it mess slides. I just mentioned this. So and how do engineers get ready? I think we need to basically we need to think about we need to have the right vision, the open mindset, and the willingness for collaboration, and the necessary skills. And most importantly, we need to have understanding and leadership. And ASCE is promoting, is viewing the civil engineers to be the right leader, right? And you can actually, during the real construction projects, all of the engineers working for civil engineers, right? So normally, at least in Hong Kong, so the civil engineer will lead all the electrical engineer, mechanical engineer, all the other engineers work together with civil engineers. So that's why we need to be on the leadership role. And there are a number of huge infrastructure projects in Greater China region. So I just mentioned the name. I cannot explore all the details. If you are interested, you can find out a little bit more. This is 3 Gorges Dam project. And this is the Hong Kong Zhuhai Macau Bridge Link project. So this reclamation project, I was the design manager for this project. So we reclaimed about 150 hectares of land. And this is in Beijing, the new airport, the Daxing International Airport. And there is another, maybe more than, I think it's more than 35 kilometers long, like a Shenzhen Zhongshan Bridge, which actually consists of bridge, immersed tube tunnel, and then a man-made island, right? So all fascinating project. If you're interested, you can find out a little bit more. Finally, a few words about Region 10. Region 10 is actually another word, ASCE Global or ASCE International. We have we have presence in 24 countries in Asia, Europe, Latin America, and Middle East, Australia, New Zealand. And that's the mission already explained by Maria. And ASCE has a vision for the engineer to be master builders and the steward of environment, innovators, and manager of risk and uncertainty. And most importantly, it should be an invaluable network for lasting friendship. Thank you very much for your attention. I wish to build this greener future together with you by innovation.
Thank you so much, Dr. Chae Li. Very nice presentation. I really like the manual calculation sheet. Actually, I still using the manual calculation and always advise my student to double check the result using the manual calculation. Thank you so much for presenting those very interesting case studies. Now, thank you so much. Now it's time to move to Mr. Mohamed Amer, the very exciting future world vision. Floor is you to Mr. Mohamed.
Thank you, Dr. Ezzat, and thank you, Dr. Chae Li and Maria for going over in great overview of first ASCE's activities and also Region 10's perspectives on sustainability and resilience. So my goal here today is to recruit you. So I am going to be very clear and upfront to all of the attendees here that for the next few minutes, you're going to learn more about ASCE's Future World Vision Initiative. And as you do that, I would like to take a picture of this slide with your phones or note down my contact information, because my appeal to you is by the end of this presentation, you send me an email and you tell me that you would like to be ASCE's Future World Vision Ambassador. And that is my goal from this presentation. What it means to be Future World Vision Ambassador, it means that you will take this presentation, that's the minimum. You will take this presentation, you will delete my name from this slide, and you will put your name on it. And you will deliver this presentation at every opportunity for speaking that you have, whether you are in academia, whether you're in practice, in private sector, in the government. We are recruiting Future World Vision ambassadors. And why we are doing that, why we are doing this program, what is the reason, I'll get into that. So Future World Vision is a major global initiative of the American Society of Civil Engineers, ASCE, that is designed to transform the way we think about our cities and the built infrastructure. So why do you think ASCE decided to make this investment to launch this mega massive initiative? And I'll use myself as an example. Back in the late 90s, I graduated as a transportation engineer who was trained to run statistical models, work in econometrics, do travel demand modeling, and worry about origin destination matrices and trip distribution, trip generation, trip assignment, and mode choice, and all of the fun stuff, right? Now, nobody at that time, this is 20 years ago, told me and my fellow transportation engineers that 20 years later, there will be a thing called smartphones where people will be using apps to do ride sharing. And then as we design our airports, there will be a need at pickup and drop-offs for Ubers and Lyfts and other ride shared services. So as I was deeply delved into the modeling side of things, I had no idea that all of that is going to get covered by the cellular data that we receive, the big data that we now use to model our transportation systems. I had no idea that there are going to be these ride-sharing apps that are going to transform the way we do pickups and drop-offs at airports. And this was just 20 years ago. So to avoid that problem from happening, ASCE launched the Future World Vision Initiative, where we drop everything that we do today. We drop our hand calculations, we drop our design software and our simulation models and our modeling software, and we sit back and we imagine realistic, deeply researched, plausible scenarios for the distant future. And why we do that is because we can then tie them back to our present day and make sure that what we are building today, what we are planning today, what we are designing and delivering today accounts for the distant future. It's an exercise in well-researched, plausible scenario-based imagination. And that is what I'm going to get into. And this is going to get very interesting. So I'm going to need all of your attention to follow how ASCE took its path towards this, right? So what is the first step that we did when we embarked on this? We said, what are the major global trends that are going to impact the distant future? First, what is the distant future, right? So we said, well, 50 years from now, this was conversation happening in 2020. So we said 2070. How is the world going to look in 2070? We just don't want to throw something at the wall and see if it sticks. We want to make sure that we deeply research it and then produce a series of products and content that drives the imagination of engineers and engineering students and general public and impacts the way we all think about infrastructure, right? So the 6 macro trends that we researched that were going to impact the distant future were the alternative energy, autonomous vehicles, climate change, smart personalized cities, high-tech construction and advanced materials, and policy and funding, right? So once we have that, what are the implications for engineers? That was the next question that needed to come, right? We urgently need to prepare for resilience in extreme environments, embrace digital models and big data use, incorporate advances in materials and technologies, understand systems dynamics and integration, and promote a culture of innovation within the profession, which is key. These are the things that we came to that we urgently needed to act upon if we were to prepare for those macro trends that are going to impact the future of our profession and the way we live in our future cities, right? So the next thing, what is the first step that we take as engineers and planners and designers? What do we want the primary impact of Future World Vision Initiative to be? Well, we want to train our minds to start thinking about the distant future. As simple as that. It is as simple as that. We are, as engineers, trained to focus on the task at hand. That's our job, and that's the job that we do really well. And we have lots of tools that are available to us to do that. ASCE's Future World Vision program provides you with tools to train our minds and start thinking about the distant future. It's a tool to stimulate, to provoke, to engage, to discuss, to debate, to question, to imagine, to reimagine. And you can ask me the question that, wow, so we are not quite sure how things are going to be 5 to 10 years from now. How can you come up with what is going to be 50 years from now? The answer to that is that what we have presented as a conversation starter to achieve this purpose is a program and a tool that is, while deeply researched, is one plausible scenario of how the future might look. The goal is not to make an accurate prediction, because that'll be a fool's errand to do that for a 50-year time frame, right? The intent is to present one deeply researched plausible scenario to get the conversation going, and in the process, get us all to start thinking about the distant future. Start asking the questions that we otherwise won't ask. Start asking the questions that I didn't ask 20 years ago when I was practicing transportation engineering and was designing airport approaches without thinking about the app-based mobility services that are going to completely disrupt and transform that whole design. So something that Maria went over, but very quick overview on what are the products that we came up with for Future World Vision. So at the heart of it is Megacity 2070, which is an interactive desktop platform that you can go to the Future World Vision website today and download and install on your computers for free. It's available in Windows platform, and it's also available for Mac users, right? So, and we'll get more into that, and we'll get into how do we use that? How do we apply it in practice and in academia? But just to introduce you to the series of products, I can tell you that every single section or every single bullet that you see on the slide is a presentation by itself, right? This is just a listing of all of the products that we have developed and we have in development. So the interactive desktop platform called Megacity 2070 is ready for you to download and experience. And we'll do a deeper dive into this in a minute, right? We also have the fully immersive virtual reality guided tour available for Oculus Quest goggles, VR goggles. So if you have access to those goggles, you can visit our website and you can download for free a 6-minute guided tour of a virtual city of 2070. And as you move through the city, you will see how it provokes your imagination and your thinking about the things that are about to come. It makes you ask questions about why certain things are presented in a certain way. It forces you to agree with certain things, disagree with certain things, identify some that are missing, and in the process, have those conversations, and again, transform the way we all think about infrastructure. There are other city worlds that are envisioned. A floating city, we have a VR guided tour available for that, for the floating city. And then also we have envisioned in conceptual stages an off-planet city, a rural city, which is an oxymoron, but that's something that we envision for the rural areas, and also a frozen city for extreme climates or for polar regions. And that's something that is in conceptual stages. Maria talked about the IMAX movie, Cities of the Future. We are all super excited about that. The purpose of that program is to expand this conversation outside of the engineering world and to take it to the public, to the general public, to grab the imagination of the general people, the public, about how the future of cities is going to look. That movie is scheduled for release in October of 2023 in Chicago at the ASCE convention. And lastly, I've listed for those in academia, there is a course that ASCE has set up on visualizing research to spark innovation. It is a fantastic experience just to listen to the conversation and think about how we can stretch our imagination just by visualizing all of the work that we do as engineers. And I strongly encourage you to look into that. Right. So I am going to talk about Megacity 2070 now. And if I may, there is before talking about the application of this desktop platform, the virtual reality desktop platform, I wanted to make sure that you are familiar with it to some extent. Now, I have about 4 minutes for which there is going to be this immersive video that is going to give you an introduction to the platform itself. But the things to keep in mind are, A, this will be running on your computers. B, you will be looking at a city of 2070 that you can toggle down to 2020 or toggle up to 2070 and see how it transforms. You will be able to see elements of the city at the city level. Think of it as Google Maps. You are looking at it from the satellite at the city level. You'll be able to zoom in and look at it at the district level, and you'll be able to zoom in further and then walk at the street level. And that's the most exciting part of the platform. And while you do all of that, there are two exciting things that will happen, right? One is that everything that you see around you, whether it's in 2020 or in 2070, there will be a tag, we call it the call out. So you'll hear that, the word call out. There will be a tag that will tell you what that technology or process is. And when you click on that, it will pop up a box that'll give you a narrative, a definition and technical description of what that is. It'll also give you a narrative on how that product or process or technology evolved from 2020 to 2070, at what point it got introduced into the future city. You'll also be able to have discussions on that topic. There is a discussion board built into the platform, and you'll also be able to look at the background research on it, including videos and other references that you can get access to. It's an amazing learning tool. And the reason why it is so important is because it's visual. So while you are learning about something, you also interact with other things and get to see other things within a city. And that's the whole concept of the interoperability and the multidisciplinary interactions that we as engineers, as civil engineers, need to have. So it's an enriching experience, and I strongly encourage you to do that. So with that, I will start a 4-minute video. And just to keep a time check, Dr. Ezzat, let me know if I need to proceed quickly after that. I just have a few examples of how you can use this and apply this in academia, if you are on faculty, if you're a student, and how you can apply this in private practice. And then I'll just wrap it up with some actions that I would really like you to take, which involves what I call becoming a future world visionary. So with that, I'm going to start the video. Let me know if the sound doesn't come through.
After logging in and moving past the tours and tutorials screen, you'll be in the city view, where you will see a wide map of the city and the surrounding region. A comprehensive story of Megacity appears on the left. To see the map evolve over time, navigate to the year selector on the right and click through the other eras. An important feature of this view is the ability to see the city through several macro lenses. Clicking these allows you to isolate specific regional realities that shape the challenges and guide the innovations in Megacity. Refer to the legends to understand these lens layers, study the data that informs them, and read a brief overview of each. When you're ready to move on, you'll see that 6 distinct districts are selectable. Click these to read about how they differ. 2 of the 6 districts are more fully explorable. When you're ready to go deeper, click on either Historic Core or Adaptive Corridor, and those will lead you to those districts. Once the district view is loaded, you'll have several options to explore. First, the lens buttons have now been replaced by systems buttons, and this is the place to understand the systems of the city. Clicking through each, you'll see a new legend appear. An overview accompanies actual data that is driven by the population density, demographics, and energy and resource requirements of this particular district. Also in the district view are key landmarks that are crucial to understanding the wider functioning of the district and city as a whole. Rolling over the callout flags extruding from the landscape will display the name of that particular landmark. Click to explore them in more detail. Let's look at the energy substation. You can move in closer and read the summary of the landmark's function. Then you can click through the steps that illustrate the process in more detail while seeing the landmark animate to further clarify. When you're ready to leave this landmark, X out and you'll return to the district. The next thing to see here is what is called a core sample, indicated with the explorable dark callout flag. Think of this as a detailed cross-section or a vertical slice of a few key city blocks. Upon selecting it, you'll notice that it's segmented into 4 distinct vertical layers. Selecting each, you can read the summary on the left and then click specific callout flags within those layers to take a closer look. When you're ready to move on, click Enter Street in the lower left portion of the text window. There will be a brief load as all of the elements of the street corner populate. Once they do, you'll find yourself seeing the city at a human scale, the streets bustling with activity. Using the various navigation methods, and for more on this, watch the Navigating Megacity tutorial video. You can wander or fly around the street corner. You can click any callout flag that interests you and zip to that spot. Here you'll see 3 tabs. On the left, you can read the technical info to understand the engineering logic or explanation for this particular callout. Then read the narrative description, which explains how this item might impact residents in their day-to-day lives. The middle tab, Discussion, allows you to add your thoughts to the conversation, which in turn might spark colleagues to add theirs. Previous comments appear below, and you can reply to those as well. Note that you'll have a choice to post your comments to all users, which is the default, or if you are a member of a private group, you can select that group from the drop-down menu here to keep your comment private. The rightmost tab is the Research tab. Open this to find the research that informed or inspired the callout. It may be in the form of a video clip from an expert interview or citations for research articles. Bookmark the callouts you want to remember so they will appear in your library, making them easy to find later. When you finish with the callout, simply click X to close it and continue on your way. Finally, there is a filter button you can use if you're only interested in seeing callout flags within a certain theme. You can find this button in the lower right corner. When you click it, a filter screen will appear with a few dozen keywords. Clicking the breadcrumbs or arrow-shaped banners at the top left of the application will help you jump back to any level you'd like to go, and you can continue your exploration from there.
So one thing I would mention is, as you saw, this is a vast city. It is easy once you get into it. It is easy to get lost in the city. So the latest version that we have now available for download, you can actually enter the city and search for what you're looking for. So for example, if I'm only interested in highway pavements, or I'm only interested in architectural facades of the future, I would go and search for that, and it will give me a list of every place where this is mentioned. And when you click on that, it'll take you straight to that point in the city. So you won't have to search for it within the city. Do check it out, do look at it, but let's very quickly, and I'll wrap it up very shortly. I know we are short on time. The application, I'll start with application and academia. How do we educate civil engineers of the future, right? I'll take in a screenshot of the desktop platform where I'm showing the programmable construction sites, right? Using that as an example, I know this is about sustainability and resilience. You could take any of the sustainability related elements and make that the focus, right? This is the slide, let's take that. And here is a sample exercise 1. I'm not going to read through all of that, but just to say, this is an instruction to the faculty member, show a call out during a class and have an in-class discussion. So now the students are not using the platform. They're just sitting back and just having an in-class discussion, the advantage and disadvantage of this idea. In this case, it's a programmable construction sites. Overall, good or bad idea, the reasons why. Focus on the social, economic, and environmental impact of that particular idea. And that generates a discussion. And you see the characteristics of this activity. It's an easy, quick to put together, and it generates stimulation and all of that in the classroom. But if you go to sample exercise 2, you will see that now you're requiring students to actually get into the platform, provide a homework assignment for which students engage in a discussion on a particular call out using the discussion board of the platform. So as you saw in the demo, every product, technology, or process that you saw in the city had its research and other information, but also has its own discussion tab that you can have discussions on, and you can have students engage in those discussions again on around the advantages and disadvantages of that idea and all of that. The great thing about that is that it has a global impact because everyone in that platform gets to see that, and you can have in-platform and off-platform conversations from it. Sample exercise 3, ask the students to pick a few callouts, 3 or 5. And again, when I say callouts, it's one of those tags, process, technology, or product. They're ideally related to each other and relevant to the course content. Ask them to perform thorough research, news and research articles, to write a term paper and develop a class presentation. And then there are all of these ideas, identifying the current research on the ideas presented in the callouts, discussing the feasibility of the ideas to happen in 50 years and so forth. So you see that is much more in depth. It's a critique and a term paper on what you are assigned to from within the platform. And these are just examples. The key takeaways in academia are that you don't need to set up a new course for this. In fact, the goal here is for you to integrate it as an exercise in existing coursework. It is also encouraged by civil engineering faculty members to reach out to faculty members in other departments and make this a cross-departmental exercise, because the future of cities touches everybody, right? It helps the next generation of students become an open-minded, critical thinkers who would embrace the idea of planning far out into the future. And this could be also used for high school recruitment events, for on-campus events, and for research, for developing research statements, and for interactive conference sessions to engage students. We had a very successful track on this at the ASCE convention that we just had last month in California. And then the last section, application in practice, very similar, but we have companies that have started using this as a beta program for employee engagement. And they have set up internal working groups, monthly meetings over lunch and learn, assignments, build personalized tours of megacity. You can do that. You can walk in the city as if you're holding a camera and make a video of what you see, what you like, post comments on discussion boards, create ideas for outreach. So again, it's lunch and learn for staff. Companies, private sector can go to your nearest ASCE section and present and engage events, discussion events at the section meeting. You could invite section members to your organizations and have discussions around these topics. Visit the local ASCE student chapters and then talk about these topics and have conversations around the distant future and all of the exciting technologies that are coming our way, disruptive technologies. And of course, outreach to local K-12 school. There is a great deal of interest in this topic. Here's an example of an internal company's online community, Amer. They're now part of WSP, but they use Future World Vision as one of the communities of their staff members who get together every couple of weeks to talk about these topics, just as a way out of their day-to-day routine. Section meetings, of course, there are all kinds of discussions that you can have at sections. What did you like about Megacity? What aspects of Megacity 27 do you think you would avoid? What challenges do you foresee? So there are all kinds of questions that can come up. You can make your own. We are in the process of creating a toolkit for Future World Vision that you will be able to access as an academic, as a practitioner, and then apply these tools. And one thing I would, there is an interactive experience for VR goggles, if that's something that you want to take that out. Before getting into how you can engage, I must also mention that much of the focus of this talk has been on the desktop application and its use in academia and private sector. But the core and most important thing to remember is that Future World Vision initiative is much larger, much broader. It includes the IMAX movie, it includes these desktop applications, it includes the VR application for goggles, the coursework that we have for universities, and a lot more. It's a philosophy that we are pushing out to our young engineers and our students. How can you engage? 5 actions, okay? Please do take at least 3 of these actions. I really look forward to hearing from you on those. Explore the Future World Vision website. We are continuing to update and upgrade the website. Explore it and learn and access especially the resources tab. If you can click on that, learn about all of the great resources related to this. Number 2, sign up to receive the Future World Vision Ambassadors Toolkit. How do you do that? Just send me an email. I've got my email on the screen. Raise your hand, sign up. Essentially, we will have this toolkit ready for you in January, but you can start, if you have the opportunity, by taking this very presentation that I just gave. And we have a lot of digital media content that you can add to it and deliver these presentations as a Future World Visionary. Spread the word around, get the conversation going. And we especially need that from an international region 10. We want this happening around the world. We have a lot of organization and sections, branches, student chapters within the United States, Canada, Mexico, but we would like internationally for the word to go out on this and people to become, to apply this and share our experiences internationally. Number 3, download and use the platform. Again, it is free. It's for Windows and Mac. You can visit the site, download, install, and explore it and apply it. If you are into Oculus Quest VR goggles, it's about a $300 hardware. This is a great tool, again, to get some excitement at events, at conferences, and at student events on campuses, recruitment events for students, and so forth. And last but not the least, take this course. This is the only item that is a paid item. It's part of the ASCE continuing education program, but you can purchase this course not only for yourself, but to deliver this as part of your existing curriculum in colleges and universities. It is fascinating. It is delivered by Jerry Walter, who's the architect behind the program. This is another video that I won't run in the interest of time, but it talks about the essence of all of the questions that came from around the world, from professionals from different backgrounds, that led to the development and launch of the Future World Vision Initiative. With that, I'll stop and we'll be happy to take any questions. And we have Dr. Lee and Maria also online to take your questions. I will stop sharing my screen. Again, do contact me and do become an ambassador of Future World Vision Initiative. Thank you.
Thank you so much, Mr. Amer. Very motivating presentation. I think you have to think about having academic position. Your structure and method of instruction is really very close to our academic APC and very well structured. Thank you so much. I'm afraid that we are very close to the deadline, but I will present my presentation very quickly. Let me please share my screen. Okay, can you see my screen now? Okay, very good. Today I will talk about the eco-friendly solution for the pavement material. As the previous presentation talked about, mainly the climate change and global warming become a very serious issue that we should be considered in different infrastructure projects. With them, we can expect very earlier infrastructure compared to what designed for. Mainly if according to our testing in our engineering lab, we examined the asphalt behavior within under the extreme hot condition and extreme cold condition, and for sure what we found that it loses up to 92% of its structural resistance upon heating, and upon cooling it's converted to be a material fragile soil and brittly failure. For sure, you experience one of those cracks nowadays, mainly become more and more everywhere in every roadway. Many types of cracks and damage and settlement and different kinds of cracks. On the other hand, the asphalt pavement as well is contributing to the global warming. Many studies express that it's release up to 300% emission more upon subjecting to solar radiation. So to cut it short, the asphalt pavement contribute to the global warming and climate change, and vice versa. Climate change affecting and deteriorating our asphalt pavement, which is the major element in most of the paved covered area. So what eco-friendly paving solution we have for the near future? I will present here the solution that it's very close to be applied much widely. First, one of the most promising solution now we have is the bio-based asphalt pavement. This type of asphalt is mainly made of non-petroleum-based renewable resources. Most of those materials are bio-based, and it can be colored, which can reduce the temperature of the road surface and reduce the urban heat island. In Netherlands, they already applied a full-scale experiment on one roadway segment. It was composed of lignin material, which is organic polymer material. The experiment succeeded, and it's expected to be used in different countries in the near future. Second is prefabricated plastic pavement. Also, the first world road constructed in this technique was also in Netherlands. This technique is composed of prefabricated plastic material, composed of recycled plastics, which is solving another dimensional problem, which is plastic waste. It could contribute in mitigating the climate change. Its cost and construction time relatively low. It could be also 100% recyclable. And here I would like to thank a group of my students. They started work on a research project in this area mainly, and they tried to print a scaled model of those prefabricated plastic model using the 3D printers we have here in our campus. Next solution is a solar pavement, which is also started to be applied. The world's first solar panel road is already open in France. In some areas, those kind of pavement called walkway. Its idea, it's very simple, is integrating the solar cell with the pavement material, but still it's in the early stage of research, because some problem still didn't solve it yet, the skid resistant problems and so on. Next is the geothermal pavement, which is integrating geothermal pipes composed of polymer material or copper material. Those kind of those pipes is transferring the heat absorbed from the asphalt into the underground subgrade layers, and exchanging the absorbed heat into a much cooler layer under the asphalt. This solution also could help in cooling down the asphalt pavement and also eliminate the early failure, reduce the maintenance cost, and could be used also for ice melting. Most recent researchers proven that investing the asphalt massive heat absorption capacity to produce electricity or electrical energy could be applicable in this system. Also, this is one of the solutions mentioned in the ASCE worldwide vision, which is a self-healing pavement. Now there is many researches running in this area, but the most common additive suggested in those research was iron oxide, steel wheeled and induction, micro capsules, including sunflower oil, and recently bacteria and enzyme start to be used in this direction. Also, the illuminating pavement, which is using some kind of materials that absorb the light during the daytime, and save it to be used up to 12 hours during the night. It could also be used for saving energy. One of the most also important issues that we should look for in our pavement connect not just our transportation network, but in the near future, it can also connect people. Most of the recent studies talk about generating energy through the pavement. So through the Internet of Things and the most promising new technology, pavement in the near future may be used in connecting the people themselves. Since we are talking about the new technology, I made a very exciting experiment. I used one of the AI applications that producing or working on the image processing. I included all the keywords I presented here today, the solar pavement, the bio-based materials, the geothermal application, and different solutions. And I feed the AI model with those keywords. And I asked him to imagine the look of the pavement in our near future. And here is the result. The AI expecting our pavement will be in yellow color. Not sure this will happen or not, but you can comment on this. It's integrating different kind of solution in one photo. With that, I end my presentation. Thank you so much for your attention. Now I'm afraid that we run out of time, but if you have any question, please feel free to share it with us in the chat box. Yes.
I will just once again add that any questions, I know there's not enough time for that. Do feel free to email me any questions, feel free to reach out, anything to follow up. And one parting advice, do not forget to enjoy the Soccer World Cup. That is your #1 priority. And then
they're already enjoying, I guess.
Number 2 is to go to the Future World Vision website and become a Future World Vision ambassador. We need our international ambassadors.
Thank you so much, Amer. Thank you, President Maria, for attending with us today. Thank you so much, Dr. Chae Li. We really enjoyed your presentation and very inspiring talks. Thank you so much.
Thank you.
Thank you.
Yeah.